Can you measure something that can circle the Earth more than 7 times in a single second? Humanity spent over 300 years, lost countless lives, and carried out some of the most obsessive experiments in history to do exactly that only. To realize we may have been measuring the bars of our own cosmic cage. For thousands of years, we believed light was instantaneous. Blink, and it was already there. No delay, no journey, just presence. But in the 17th century, a simple question began to shake the foundations of reality itself. If light has a speed, could we ever hope to catch it? Galileo Galilei was the first to challenge the darkness. Standing on distant hilltops with oil lanterns, he tried to measure whether light hesitated, even for a moment, as it traveled between them. The result was a complete failure. Human reaction time was far too slow, like trying to time a lightning strike with a sundial. To Galileo, light appeared almost divine, mocking every crude attempt to measure it. The breakthrough came not from Earth, but from the sky. In the late 1600s, Danish astronomer Roemer studied Io, a moon of Jupiter. He noticed something strange. When Earth moved farther away from Jupiter, Io's eclipses appeared late. When Earth moved closer, they came early. The only explanation was unavoidable. Light was taking time to travel. Roemer calculated the first finite value for the speed of light, about 210,000 kilometers per second. It was off by roughly 25%, but for the first time in history, light was no longer infinite. It had a number, a limit. The 19th century turned that revelation into obsession. Scientists began building machines designed solely to trap light long enough to measure it. Hippolyte Fizeau used a rapidly spinning toothed wheel to block and unblock a beam of light. Later, Albert Michelson, a U.S. naval officer, devoted his entire life to refining the measurement. He built long vacuum tubes stretching across mountains and deserts, firing beams of light across miles of open air. His pursuit became so absolute that he continued refining the number even while seriously ill, driven by the belief that this constant mattered more than any single human life, including his own. Then, in 1983, something extraordinary happened. Scientists announced that we would no longer measure the speed of light at all, not because we failed, but because we succeeded too well. The speed of light was declared an absolute constant of nature, fixed forever. From that moment on, the meter itself was defined by how far light travels in a fraction of a second. Light was no longer something we chased. It became the ruler by which we measure reality. But here is the unsettling truth. The speed of light is not just a number, it is a limit. As the universe expands, vast regions of space are being carried away from us faster than light can ever reach. Not because objects are moving through space faster than light, but because space itself is stretching. The result is a cosmic horizon beyond which information can never arrive. Most of the universe so far beyond what we can ever observe is already unreachable. After 300 years of chasing light, we finally understood it, only to discover that it defines the edge of everything we can know. Light lets us see the past, but it also draws a boundary around the future. Whether that boundary is a gift that gives meaning to what we can observe, or a limit waiting to be challenged by ideas not yet born, remains an open question. So, what do you think? Is the speed of light the greatest tool humanity has ever discovered, or the final wall we have not yet learned how to cross?